Dear students of Standard 9, welcome back to your higher mathematics class. This is Mohammad Absharkar. Now I am going to take my third class on chapter 1. In my previous classes, I have discussed about function and classification of function. Today I am going to solve problem of this exercise 1.2. I have already solved in your class up to 10.1. Now I am going to solve 10.2 to 12 today. 10.2. For function f real number to real number, f of x equal to x cube. Show that f is one on function. First of all, we have to know the definition of one on function. In one on function, images of different element are distinct. Images of different element are distinct. Here we can prove this. We can show this problem contradictorily. Let for some AB belongs to domain, their images are same. Our definition is different element, images of different element are distinct. Here we can relate images of two elements same. Then we get f of a equal to f of b. Here images of a equal to f of a, image of b equal to f of b. Relate f of a equal to f of b. Now place a in place of x, you get a cube, and place b in place of x, you get b cube. Now applying cubic root on both sides, you get a equal to b. That means here relate images are same and get element are also same. Images are same, then you get element are also same. Therefore, if images are same, then also element are same. So image of different element are distinct. Image of different element are distinct. So this function f is 1, 1. Clear? For function, I have to find the inverse of the function. Let y equal to this function, y equal to f of x, y equal to f of x. Then changing side of the function, you get inverse. Here this side, right side f is f. If it's change this to left, then you get f inverse. Changing side of function, you get inverse of this function. Then x equal to f inverse y. Y equal to f of x, then x equal to f inverse y. Here f changing side, then become f inverse. Now our supposition is y equal to f of x, y equal to f of x, and the value of f of x equal to x cube. Now applying cubic root on both sides, you get x equal to cubic root of y. But we get here x equal to f inverse y, putting the value of x, we get f inverse y, x equal to f inverse y, x equal to f inverse y equal to cubic root of y. Now f inverse x equal to, we place x in place of y, then we get this f inverse x equal to cubic root of x. And this is the inverse function of this function. So clear? This is the inverse of this function. Here f inverse is the inverse of this function. For a function real number to real number, to show real number to real number f of x equal to x cube, show that f inverse is a function. We have to show f inverse is a function. To show f inverse is a function, we have to show f is 1, 1 and on 2. If we show that f is 1, 1 and on 2, then it is showed that f inverse is a function. Another way I can show you another way. Now I am showing you another way. F inverse x equal to this, from 3 we get f inverse x equal to this. This F inverse is valid for every element of this domain. Every element of this domain. F inverse is valid for every element of R. And image of every element is unique here. 1, 1, 2, cubic root of 2. So image of every element of R is unique under this F inverse. So F inverse is a function. Now 11.1. F is a mapping from real number to real number is a function which is defined by f of x equal to ax plus b. A b belongs to real number and a not equal to 0. Why a not equal to 0 is needed? I will show you. Show that f is 1 on and on 2. To show f is 1 on, we have already solved this type of question in 10.2. Similarly, let for some x1, y, x2 belongs to domain and their images are same. Therefore, place x1 in place of x, you get ax1 plus b, and x2 in place of x, you get ax2 plus b. Now subtracting both side b, on both sides you get ax1 plus ax2, ax1 equal to ax2. Now dividing by a, on both sides you get x1 equal to x2. That's why a not equal to 0. In case of division, if denominator is 0, then the fraction is undefined. So that's why a not equal to 0 is given. Therefore, you get x1 equal to x2. Same case, if images are same, then also elements are same. So images of different element are distinct. Clear? So f is 1 on. Now to prove f is on to, let y be any arbitrary element of codomain. Here R is not domain, here R is codomain. Y be any arbitrary element of R, codomain, and we know from the definition of onto function, every element of codomain is associated with at least one element of domain, and let y be any arbitrary of element of this codomain, and for this y you get at least one x belongs to R. For every y, we get at least one x belongs to R such that f of x equal to y. F of x equal to y, then the function is onto. We let y belongs to R. If we let, then we get x equal to y minus b by a. This x plus b equal to y, and then x equal to y minus b by a. If we let 1 belongs to R, therefore we get 1 minus b by a. If we let 2 belongs to R, then we get 2 minus b by a equal to x. That means for every element of R, there exists at least one element of x belongs to R such that f of x equal to y. Therefore f is 1 to. F of x f of y minus f of x, that means f of y minus b by a, y minus b by a, in place of x we get, in place of x we place y minus b by a, y minus b by a, cancelling a and subtracting and cancelling b, we get y. Therefore f is 1 to. Clear? Now 11.2, similar with any arbitrary element x1 x2 belongs to this domain. For this 2, f of x equal to x1 equal to f of x2, placing x1 in place of x, then we get this 2, and squaring on both sides you get this, and cancelling 1 on both sides you get this. This equal to x1 square, this x1 squared, that's why plus minus root over of x2 square. But Here we can see that x1, x2 both are belonging in this closed interval. This closed interval is from 0 to 1. That means non-negative. The number of this closed interval are non-negative. So x1 equal to x1 equal to x2 because x2 non-negative. x1, x2 are non-negative. So x1 equal to x2. Therefore, if images are same, then also elements are same. So image of different element are distinct. So therefore, f is 1 1. Clear? Now I have to show f is onto. Similar, let y be any arbitrary element of this codomain, and we have to show at least uh, one element x belongs to this domain for this y, such that f of x equal to y, and let uh, y equal to this. Therefore, we get x equal to this. Here also x equal to plus minus root over of 1 minus y square, but as x belongs to this domain, so x is non-negative. Therefore, only positive sign is taken. Clear? X is now for this x, f of x equal to y. onto ফাংশনের ডেফিনেশন হলো ডোমেইনের কোডোমেইনের সবগুলো এলিমেন্ট কারো না কোনো এলিমেন্টের ইমেজ হবে। তাই আমরা যে কোনো একটা এলিমেন্ট ধরছি y, যে কোনো একটা এলিমেন্ট ধরছি কোডোমেইনের মধ্যে, তার জন্য একটা x পাচ্ছি ডোমেইনের মধ্যে, যেটা f of x equal to y হচ্ছে। তাহলে যে কোনো y যদি ধরি তাহলে সবার জন্যই হবে, যে কোনোটাই ধরছি তার জন্যই হচ্ছে, তাহলে তো সবার জন্যই হবে। তাই এই ফাংশনটা onto. Clear? If function f from real number to real number are defined by f of x equal to x cube plus 5 and g of x equal to x minus 5 cubic root, then show that g equal to f inverse x. We already learned how to find inverse of a function. Let y equal to f of x, and then changing side of this function you get f inverse, then x equal to f inverse y. Now our supposition is y equal to f of x. Now placing the value of f of x, x cube plus 5. Now x cube equal to y minus 5. Now cubic root on both sides, x equal to y minus 5 cubic root. But this x equal to f inverse y, so f inverse y equal to y minus 5 cubic root. Now f inverse x equal to x minus 5 cubic root. F inverse x minus 5 cubic root. This is the inverse of the function f. F is a function and f inverse is this. But given g of x equal to this are same. G of x equal to x minus 5 cubic root. F inverse x also x minus 5 cubic root. Therefore, g equal to f inverse x. F inverse. Should. Now, 12.2, if function f real number to real number are defined by f of x, then find the inverse of the function. Here we have to find the inverse of the function. Solution, let y equal to f of x, but here we take p because y already given. We let p equal to f of x, so f inverse p equal to x, so x equal to f inverse p. Now our supposition is p equal to f of x and f of x equal to 5x minus 4. Now changing side, 5x equal to p plus 4. Now dividing on both sides by 5, we get x equal to p plus 4 by 5. Now x equal to f inverse p, so f inverse p equal to p plus 4 by 5. Now place x in place of p, get f inverse x equal to x plus 4 by 5. This is the f inverse x. So therefore, y equal to f inverse x equal to x plus 4 by 5. this is all for today. If you have any question and any suggestion, write on your own group or in comment box. Thank you.